Ever wondered how new mathematics come to life? How do mathematicians conjure up fresh theories, proofs, and concepts that push the boundaries of our understanding? Today, we're going to demystify that process, breaking down the steps involved in creating new mathematics. Step 1, identify a problem or gap. This is where it all begins. Mathematicians are like explorers, venturing out into the vast landscape of numbers and equations, searching for areas where current theories might fall short or where questions remain unanswered. Step 2, study existing mathematics. Before crafting something novel, a solid grasp of existing mathematical theories and principles is crucial. This involves delving into various branches of mathematics to glean insights into different approaches and methodologies. Step 3, formulate hypotheses. Armed with knowledge and curiosity, it's time to make educated guesses or conjectures. These are proposed statements believed to be true but haven't been proven yet. Step 4, develop theories and proofs. This is where the magic happens. Using the hypotheses as a foundation, new theories or mathematical structures are developed. Proofs are constructed to validate these theories, ensuring their correctness through rigorous logical reasoning. Step 5, collaborate and seek feedback. Mathematics is a community effort. Sharing ideas with other mathematicians, professors, or researchers can provide valuable feedback and critiques, helping to refine theories and proofs. Step 6, publish and share. Once robust theories and proofs have been developed, they're ready to enter the wider mathematical world. Publishing in academic journals or presenting at conferences allows for peer review and further collaboration. Finally, step 7, iterate and refine. Mathematics is a field in constant evolution. Even groundbreaking discoveries may need revisions or refinements over time. Staying open to feedback, continuing to study, and being willing to iterate on ideas is part of the process. To summarize, creating new mathematics is a journey, one that requires patience, persistence, and a willingness to embrace uncertainty. It's a process of exploration, discovery, and refinement, a puzzle that mathematicians unravel piece by piece. So, the next time you encounter a mathematical concept or theorem, remember the journey it took to get there. The exploration, the hypotheses, the rigorous proofs, the collaboration, and the continual refinement. And who knows, perhaps one day you'll be part of this incredible process, pushing the boundaries of mathematics and contributing to its ever-evolving landscape. Remember, every new mathematical journey starts with a single step: a question, a curiosity, a gap waiting to be filled. Let's take a quick detour from our journey and explore a fascinating mathematical puzzle: the magic square. A magic square is a grid of numbers, usually positive integers, arranged so that the sum of the numbers in each row, each column, and both main diagonals is the same. This sum is known as the magic sum. For instance, let's take a look at a 3x3 magic square. We have the numbers 1 to 9 arranged in such a way that every row, column, and both diagonals add up to 15, the magic sum for this square. But how do you construct a magic square? There are various methods, but one simple way for a 3x3 square is to start by placing the number 1 in the middle of the top row. Then move up and to the right, wrapping around the edges if necessary, and fill in the next number. If a cell is already filled, move down one square and fill in the number there. Magic squares are engaging challenges that combine mathematical principles with logical reasoning and pattern recognition, offering a rewarding experience for puzzle enthusiasts and mathematicians alike. So why not give it a try and start your own mathematical journey? As we continue our exploration, let's delve into an ambitious and thrilling endeavor of constructing a new branch of mathematics, focusing on patterns and their underlying structures. This journey is not for the faint-hearted, as it demands a profound understanding, creativity, and rigorous logical reasoning. Our goal is to formalize the study of patterns, providing tools and techniques for analyzing, describing, and predicting patterns across a range of fields, including mathematics, science, art, and nature. Patterns often reveal underlying structures that govern their behavior and appearance. These structures can be represented mathematically through equations, algorithms, or geometric properties. To develop our new branch of mathematics, we will consider the following approaches: pattern recognition, pattern generation, pattern analysis, pattern prediction, and pattern representation. Let's break down these steps. Pattern recognition involves identifying and interpreting patterns and regularities in data. Pattern generation is about creating new patterns using mathematical rules or algorithms. Pattern analysis delves into understanding the nature and structure of patterns, while pattern prediction focuses on forecasting future patterns based on current data. Finally, pattern representation is about visualizing and modeling patterns in a comprehensible manner. Interdisciplinary connections will also play a crucial role in this journey. By combining theoretical insights with practical applications, we can develop a comprehensive framework for understanding patterns and their underlying structures. This journey will be a constant cycle of iteration and refinement. Be prepared to collaborate with others, adapt to new challenges, and share your findings as we work together to construct this new branch of mathematics. The road ahead may be challenging, but the rewards will be substantial. So, are you ready to embark on this exciting journey? Our next stop on this mathematical journey is an intriguing puzzle that has fascinated scholars for centuries: the 3x3 magic square. This square, filled with digits from 1 to 9, is considered magic because the sums of the numbers in each row, column, and diagonal are all equal. Let's break this down. Imagine a 3x3 grid where each cell is assigned a unique letter from A to I. Our task is to fill this grid with the digits 1 through 9 in such a way that the sum of the numbers in each row, a plus B plus C, D plus E plus F, G plus H plus I, each column, a plus D plus G, B plus E plus H, C plus F plus I, and each diagonal, a plus E plus I and C plus E plus G, equals 15. Given these constraints, there are multiple possible arrangements of the digits 1 through 9. Let's take a look at one such arrangement. The top row is 8, 1, 6. The middle row is 3, 5, 7. The bottom row is 4, 9, 2. The sum of each row is 8 plus 1 plus 6 equals sign 15, 3 plus 5 plus 7 equals sign 15, and 4 plus 9 plus 2 equals sign 15. The sum of each column is 8 plus 3 plus 4 equals sign 15, 1 plus 5 plus 9 equals sign 15, and 6 plus 7 plus 2 equals sign 15. The sum of each diagonal is 8 plus 5 plus 2 equals sign 15, and 6 plus 5 plus 4 equals sign 15. As you can see, this arrangement fulfills all the conditions of a magic square. This illustrates the underlying structure and pattern within this ancient mathematical puzzle. Understanding these patterns is key to unlocking the magic square and provides us with a fascinating glimpse into the world of patterns and structures in mathematics. Let's delve deeper into this concept of the magic sum. The magic sum is the total sum of any row, column, or diagonal in a magic square. For a 3x3 magic square using the digits 1 to 9, the total sum of all the digits is 45. This is divided by 3, the number of rows or columns, resulting in the magic sum of 15. Thus, every row, column, and diagonal in a 3x3 magic square using the digits 1 to 9 should add up to 15. Now, to add a twist to our exploration, let's consider the properties of numbers when they're reversed. For instance, the number 45 becomes 54 when reversed. If we consider these as powers, 4 to the power of 5 equals 1024, and 5 to the power of 4 equals 625. Interestingly, if we reverse these results, we get 526 and 421 respectively. These equations are not just intriguing coincidences, they reveal deep and fascinating patterns that exist within numbers. Understanding these patterns can lead to new insights and discoveries, showcasing the beauty and complexity of mathematics. This exploration of patterns and relationships is a vital part of our journey into the world of mathematics. Stay tuned as we continue to unravel the mysteries of the mathematical universe. Just as we began to unravel the mysteries of the magic sum, we've stumbled upon another intriguing concept, the reversal of digits and numbers. This concept branches out into a whole new world of mathematical patterns and relationships. Let's break down these equations and see what they reveal. When we reverse 45, we get 54. In terms of powers, 4 to the power of 5 equals 1024, and 5 to the power of 4 equals 625. If we reverse these results, we get 526 and 421 respectively. Do you see the pattern? It's not just a simple reversal of digits, it's a fascinating interplay of numbers and their powers. Now let's take a look at another number pair, 52 and 26. When you add 26 to 26, you get 52. Similarly, if you add 21 to 21, you get 42. These equations further illustrate the intriguing relationships among numbers and their digit arrangements. These patterns are not mere coincidences. They are a testament to the richness and beauty of mathematics. They highlight the endless possibilities that can be discovered through exploration and creativity. As we delve deeper into this mathematical journey, we find ourselves constantly amazed by the intricate patterns and relationships that exist within numbers. The world of mathematics is indeed a fascinating universe waiting to be explored. Stay tuned as we continue our journey. Having delved into the concept of number reversal, let's explore some fascinating numerical patterns and relationships further. Our first stop is at the intriguing properties of digit reversal. As we've seen, reversing the digits of a number can lead to surprising results, enriching the mathematical tapestry with unique patterns. Moving on, we encounter the intriguing patterns of exponential equality. Take 25 and 52, for instance. 2 to the power of 5 equals 32, and 5 to the power of 2 equals 25. Notice the pattern? The results are reversals of each other, showcasing the symmetry inherent in mathematical relationships. Next, we turn to the sum of digits and its unique relationships. For example, the sum of the digits of 123 is 6, and the sum of the digits of 321 is also 6. This pattern extends to other numbers, revealing a fascinating consistency. Digit rearrangement offers another intriguing perspective. It's amazing to see how rearranging the digits of a number can yield a completely different number. Yet certain relationships remain intact. This showcases the flexibility and symmetry of numbers, further enriching the mathematical landscape. Finally, we see the combination of these patterns, revealing the interconnectedness of different numeric properties. The beauty of mathematics is in these intricate relationships and patterns which become apparent as we explore and experiment. Our exploration reveals the beauty and intricacy of numerical patterns and relationships. Enriching our understanding of mathematics, it's a reminder of the endless possibilities that await us in this fascinating universe of numbers. So let's continue our journey, always ready to discover and learn. Moving forward on our mathematical journey, let's delve deeper into a captivating concept: the reversal of digits in numbers. This seemingly simple operation can lead to the discovery of new mathematical patterns and relationships that further enrich our understanding. Consider the numbers 45 and 54. At first glance, they appear as mere reversals of each other. However, delve a bit deeper and you'll find that the sum of the digits remains the same. In both cases, it equals 9. This pattern holds true for other numbers as well, such as 1024 and 4201, where the sum of the digits is 7. Now let's explore an even more intriguing pattern. Take the number pairs 16 and 61, 25 and 52. Do you notice anything peculiar? Yes, you got it. 6 to the power of 1 equals 6, and 1 to the power of 6 also equals 1. Similarly, 5 to the power of 2 equals 25, and 2 to the power of 5 equals 32. The results are reversals of each other, demonstrating a fascinating symmetry and interconnection within the world of mathematics. These patterns are not mere coincidences, but rather, they are inherent properties of numbers that become apparent through digit reversal. They showcase the beauty and complexity of mathematics, reminding us that even within the simplicity of numbers, there lies a world of patterns and relationships waiting to be discovered. So as we continue on our journey, let's keep these insights in mind, always ready to discover, explore, and learn more about the fascinating universe of numbers. In our captivating journey through the world of numbers, we've stumbled upon a fascinating observation about exponentiation. Let's consider the numbers 45 and 54. These numbers are not just simple reversals of each other, but they also share a unique property in the universe of exponentiation. If we express 45 as 4 to the power of 5 and 54 as 5 to the power of 4, surprisingly, Both of these expressions yield the same result, 1024. Isn't that intriguing? How about another pair, 36 and 63? That's right, 3 to the power of 6 and 6 to the power of 3 both give us the same result, 729. This property, where reversing the digits in the base and the exponent leads to equality, provides a fascinating glimpse into the world of exponentiation. It's yet another testament to the innate symmetry and interconnectedness that exists within the realm of mathematics. As we continue to unravel these patterns and relationships, we're reminded of the immense beauty and complexity that lies within the simplicity of numbers. So as we delve deeper into our mathematical journey, let's keep these insights in mind, ready to uncover more hidden gems in the vast universe of numbers. Remember, in the world of mathematics, there's always something new to discover. Switching gears a little, let's now turn our attention to the sum of digits in a number. Have you ever noticed that certain numbers exhibit a peculiar symmetry when their digits are rearranged? Let's take 52, for instance. If we break it down into 26 plus 26, we get the original number back. Fascinating, isn't it? Now let's consider another number, 42. If we rearrange its digits, we can express it as 21 plus 21. Once again, we get the original number back. This property, where a number can be expressed as the sum of two identical numbers when its digits are rearranged, reveals the inherent symmetry in numbers. It's like a hidden puzzle waiting to be discovered in the world of digits. As we continue to explore these intriguing patterns, they lead us to new insights and discoveries showcasing the beauty and complexity of mathematics. So let's keep our minds open, ready to be amazed by the subtle elegance and profound depth that lies within the simplicity of numbers. Remember, the world of mathematics is full of surprises, and there's always something new waiting to be discovered. Having seen the magic of sum of digits, let's now dive deeper into the world of digit rearrangement. Did you know that simply rearranging the digits of a number can give you an entirely different number? Let's take a look at the number 526. If we rearrange the digits, we can get 421. Interesting, isn't it? But that's not all. If we elaborate this further, we can even get 52631 from 68421. This just goes on to show the immense flexibility and symmetry that is inherent in the numeric representations. It's like a game of numbers where each rearrangement leads to a new discovery. These patterns and structures hidden within the numbers are not just fascinating, but they also reveal the intricate beauty and complexity of mathematics. So keep exploring, keep discovering, because the world of mathematics is full of surprises. And who knows, the next big discovery could be just a digit away. Having delved into the power of digit rearrangement, it's time to take a step further into the realm of combining patterns. Mathematics is not just about individual numbers or patterns, but also about how these patterns interconnect and interact with each other to create more complex equations. Let's take a look at some intriguing combinations. Consider the equations, and do you notice something extraordinary? Not only do these equations illustrate the symbiotic relationship between addition and multiplication, but they also showcase the interconnectedness of different numeric properties. Each of these equations represents a unique pattern, a unique structure. But when combined, they reveal an even richer tapestry of mathematical relationships, each more complex and intriguing than the last. So as we dive deeper into the world of mathematics, remember that understanding these patterns and their combinations can lead to new insights and discoveries. It's all about exploring the beauty and complexity of mathematics. After all, every pattern, every number, every equation has a story to tell. So let's keep exploring, keep discovering, and who knows, you might just stumble upon the next big mathematical breakthrough. Our exploration doesn't just stop at small numbers. It extends to larger numbers as well. As we've seen, mathematics has an inherent flexibility that allows for the rearrangement of digits to form new numbers without changing the intrinsic value of the original number. A fascinating example of this is the equation 5263157 equals 7368421. If you look closely, you'll see that the digits of the first number have simply been rearranged to form the second number. This property reveals the inherent flexibility and symmetry in numbers. a trait that might seem trivial at first but can have profound implications in the study of patterns and structures. Remember, in mathematics, the size of the number doesn't necessarily determine its importance. Even the largest number can have properties that are mirrored in the smallest of digits. So, as we continue our journey of discovery, let's not forget to appreciate the beauty and complexity of mathematics in all its forms. After all, it's the patterns, the structures, the relationships that make this field so incredibly fascinating. So let's keep exploring, keep pushing the boundaries, and perhaps we'll uncover even more intriguing mathematical phenomena. In the spirit of further exploration, let's delve deeper into these patterns. An interesting equation to consider is, what does this equation tell us? It reveals that there are additional relationships hidden within the numbers we've been studying. Notice how the sum of the digits in 7368421, which is 16, equals the sum of the digits in both 68421 and 52631. And this sum, in turn, equals the sum of two identical numbers, 8 plus 8. This symmetry, this balance, is what makes mathematics so incredibly fascinating. It's like a beautiful dance of numbers, where every step, every move is intricately connected. And understanding these patterns, these connections, can lead to new insights and discoveries. So, as we continue to delve into the beauty and complexity of mathematics, let's remember to always keep an open mind, to always look for these hidden connections because they might just lead us to something absolutely extraordinary.